Today I am going to solve one get fluid mechanics question. So here question is for a hydraulic lift with dimensions shown in figure. Assuming G is 10 meter per second square, the maximum diameter D left in M that lifts a vehicle of mass 1000 kg using a force of 100 Newton is dash. Here we have to calculate D left. Round up to 2 decimal place. So this problem actually the application of Pascal law, and that is that application on hydraulic lift. Now how that force applied get lifts and work. So actually it is based on the principle of equal pressure transmission throughout the fluid. So here a narrow cylinder, you can say this is the narrow cylinder, is connected a wider cylinder, so that is B, fitted with airtight piston. So here is one piston, here is another piston, filled with an incompressible fluid. So this is filled with incompressible fluid. The mathematical representation of the Pascal law helps in the determination of pressure which can be exerted on the fluid in the piston, so it creates enough force for lifting and moving an object. Now here in the small cylinder there should be some force to that to the piston, and that will create pressure, and that pressure will transmit through that large piston, and it will create the lift which will lift heavy object. Now what is Pascal law? The pressure applied to a confined fluid within an enclosed container is transmitted undiminished in the all direction throughout the fluid and to the walls of the container. Means, so here in that small cylinder some force will apply, so that will create pressure, so that pressure will transmit throughout that fluid, and that will give that to that large diameter cylinder, larger diameter piston, and that will create a large force, and that will lift heavy machinery or car. You know, in hydraulic system, Pascal law allows a small force applied to the small piston to generate a large force on a large piston connected through a confined fluid. This amplification of the force is essential for lifting heavy loads and performing various mechanical tasks. Now, according to the Pascal law, so that is P1 is equal to P2, means whatever pressure generate in that small piston, so P1, so that is, we know pressure is force by area, so that P1 F1 by A1, and here so that pressure is transmit to that large diameter piston. Okay, so that let's say pressure here is P2, so that will create some force, so force is F2, and area of that piston, if diameter is there, so we can easily calculate, so F2 by A2. Now we know according to Pascal law P1 is equal to P2, so P1 is equal to P2. Now P1 is actually F1 by A1, that is equal to F2 by A2. Now we can also write F1 A1, if diameter is given, so we can write pi d1 square is equal to F2, so that is pi d2 square. Now pi will be cancel out, so we can write F1 by d1 square is equal to F2 by d2 square. Now in our, so we know that, so now in our problem, so we can write F1 by d1 square is equal to F2 by d2 square. So that we got from Pascal law. Now data given. So we get this formula from P1 is equal to P2. Data given, so F1 is given, F1 is 100 Newton, D1 that is D left, so that is given, or no, that is that we have to calculate, and F2 is given, F2, so that is 100 kg mass, actual 100 kg mass of that vehicle, mass will be lifted by the force. So F2 will be, we know force is equal to mass into acceleration. So mass is given, so that is 1000 into G is 10 Newton, and D2, so that is given 2 meter. Now we can put that here. F1 is 100 by D1 square, that we have to calculate D1, and F2, that is 1000 into 10 by D2. D2 is 2 square. Now that 2 here, that will cancel out, so we'll get 1 by D1 square is equal to 100 by 4. Now D1 square will be 1 by 25. 1 by 25. So that will be 1 by 25. Okay, now we have to calculate D1. D1 will be root over of 0.4, that will be 0.20 meter. Now answer D left will be 0.20 meter. So that will be the answer. Answer is 0.20 meter. That is the answer. Answer 0.20 meter. The diameter of the nanotube is 0.20 meter. That's it. Thank you.